So today we're going to be talking about polynomial functions. It's a review of what we did last year in Algebra 2, so we're going to kind of breeze through some of it. Some of it we'll have to go through a little bit more carefully. So we're going to be talking about graphing the polynomial function. F of x equals x to the 6th minus 1. I'm going on the assumption that from here you would be able to make a table as opposed to just copying one from the calculator, because this would be a section you probably wouldn't be using a calculator on in your next quiz. So you're going to make the table. When you make the table, you're going to end up with a graph. You should end up with a graph that looks like this. And again, I'm going on the assumption that you've made a table. That table would find, when you complete the table, you should be able to see that it's going to create a graph. It's going to look much like a parabola, and just like a parabola, because it has the -1 in the equation, it would be translated down 1. If you look in your book, the next section would have information on the polynomials and talking about the end behavior. Notice that when we have a polynomial that has an n as odd, which means we're talking about our variable as odd. When our variable is odd and our leading coefficient is positive, the end behavior will look like this. So we're going to talk about it being negative as x goes to negative infinity, and going to positive infinity as y goes to positive infinity. If I switch that around and have an odd exponent with a negative leading coefficient, it would switch it around. So as x goes to negative infinity, y goes to positive infinity, and as x goes to positive infinity, y goes to negative infinity. And then I would have the same thing over here. When I have something that I have a even exponent, if I have an even exponent and a positive leading coefficient, both of them are going to go to positive infinity. And if I have a negative even exponent and a negative leading coefficient, then it would be going down to negative infinity. And again, all of these charts are in your book. Plus, we did it all last year, so hopefully it should look familiar. I can also talk about zeros and turning points. Notice that when I have a number of zeros, it's going to have the same exponent, same as the number of exponents. So in this case, since I have an x to the 6th, that tells me that I can have 6 zeros, and then at most. And then when I talk about my turning points would be 1 less than the highest degree. So the highest degree is 6, so that means I'm going to have 5 possible turning points. Now you can see if I look at this graph over here, I'm only going to have 1, 2, 3 turning points, but I would have at most 5 turning points. And I also only have 1, 2, 3 zeros, but again, at most I could have 6. So here's my next question. If I have an equation, f of x equals x cubed plus 5x squared plus 4x, I want to know the number of zeros. So if I look, my degree is 3. Since my degree is 3, that tells me there is at most 3 zeros. Since my degree is 3, I can also find out the number of turning points by taking the degree and subtracting 1. If I take the degree and subtracting 1, that tells me I only have 2 turning points, and that's again at most. To actually find the zeros, then I would need to factor. So I would take my equation that I'm given and set it equal to 0. As you can see, it's got a greatest common factor, so I would want to take the greatest common factor out, and then I would take this polynomial here and try to factor that, and lucky for us, it does factor. Once I have those factored, then if I wanted to, I could set each of those factors equal to 0 in order to find out where my zeros actually occur. And I would have one at 0, I had have one at -4, and I would also have another one at -1. If I look at the graph of that particular function, this would be what it would look like. And there's my zeros at 0, at -1, and at -4. I can see that I have 1, 2 turning points. And as I said, we have 3 zeros and 2 turning points, which is exactly what I could find by looking at the degree, because the degree is 3. I would have 3 zeros and 2 turning points at most. I can also talk about quadratic form. Quadratic form is when we talked about last year. We talked about it being a u substitution. So if I have something that has an x to the fourth, I can make u x squared. So I could rewrite it as I did here, x squared, and wherever you see the x squared, I could make it a u squared. So u squared minus 5u minus 14 makes it so that it's a quadratic form because a quadratic equation has an x squared, or in this case a u squared, and then I could just factor that from there. You could certainly also factor it as written right from the x to the fourth if you wanted to, so you really wouldn't have to make that u substitution if you don't want to. It's just a choice if you find it easier to do that. So we're going to be using that u substitution in this problem. If you look, my problem h of x equals x to the fourth minus 4x squared plus 3. I can see that my degree up here is 4, so that means I'm going to have at most 4 zeros, and I'm going to have at most 3 turning points. So then I now need to figure out what the zeros actually are. So if I make a u substitution, because I have an x squared in that one, and I have an x squared in that one, u would be x squared. So then I would have x squared squared minus 4x squared plus 3, which would, if I substitute that in, u squared minus 4u plus 3, and then I would have to solve or factor that particular polynomial, and I would have x minus 3 and x minus 1. Now, if you don't want to make that u substitution, I could also say and factor it as x squared minus 3 times x squared minus 1. Now, in each of these terms, I'm now going to need to keep going to the next step, because either I would factor the ones as I've written, so I could rewrite that as factor those as x plus the square root of 3 and x minus the square root of 3, and then x plus 1 and x minus 1. Or I would have to do a u substitution. When I do a u substitution, I would have to replace this u with what u actually is, which is x squared, which I'll show you on the next slide. If I do my u substitution, here I've replaced my u with x squared. So I have x squared minus 3 and x squared minus 1, which kind of gets us into the part that we had before, where I would need to factor it. So there, if I factor it, I get all of those 4 terms that are there, which I could then set equal to 0 and solve for x. So then I have my 4 zeros at positive square root of 3, negative square root of 3, positive 1, and negative 1. We also found in our particular equation, since it was x to the fourth, I would have at most 4 zeros and 3 turning points, which in order to figure out my turning points, you'd have to make a table to graph. But if I were to graph it, it would look like this. And there are my 4 zeros, like we found before, and my 3 turning points. I have 1 here, 1 here, and 1 here. So there's my at most 4 zeros and 3 turning points. And then the last one, h of x equals x to the fourth plus 5x cubed plus 6x squared. Again, since it has a degree of 4, that means that my zeros I have at most are 4, and my turning points at most is 3. So then I would have to factor that. So I would want to factor by taking out the greatest common factor, and this time my greatest common factor is x squared. So then I would then factor my polynomial of x squared plus 5x plus 6, which can factor into x plus 3 and x plus 2. And then I can set each of those equal to 0. So in that case, I would have that x is going to equal 0, x is going to equal negative 3, and x is going to equal negative 2. So this time, I only have 3 answers, even though I said at most I could have 4. Remember back when we talked about it last year, x squared is going to have a double root or a multiplicity of 2. We'll talk a little bit more about multiplicity, I think tomorrow. But when it has a multiplicity, that means that the x squared, because it's got a variable of a squared, that the multiplicity means there are 2 of those zeros. And then x equals negative 3 and x equals negative 2 would be what my traditional answers are. That really isn't anything new. Again, if I were to graph it, oh, there we go. There's all my answers, and we talked about that. We have 3 zeros and turning points. We'll see in just a second when I show you the graph. And there is my graph. Notice that I have my 1, 2, 3 zeros. Remember, since it comes down and it only bounces off the x-axis, that's what sort of shows me that I have a multiplicity of 2. When I have something that has a double root or a multiplicity, it just is going to come to the axis or come to, in this case it is going to be the axis because it's a 0. It will come to the x-axis and bounce back up. It doesn't cross over the x-axis, it just comes to the axis and bounces back up again. And then again, you can see that I'm going to have my 3 turning points, 1, 2, and 3, which I found by saying that most I was going to have 3 turning points because it's x to the 4th. So the next time I see you, we will be working more with these graphs, and this time when we do it in class, I will actually have you graph some functions, so be prepared for that. We will be using tables, so we'll be taking a little bit longer to do the graphs as opposed to what we just did here where you were looking just at graphs already prepared for you. Hopefully you haven't done any questions. If you do, jot them down and I'll answer them tomorrow. Thanks.